Hey guys, welcome to another episode of my channel. So today we are going to talk about this piece of equipment. This is RFID-RC522. This device is designed as transmitter receiver for RFID cards and tags, and it can also work with a lot of NFC cards and tags, because as you know, NFC is branch of RFID technology. So basically what we can do with this device, we can read and write data from our cards and tags. And for this episode I don't intend to go deeply into this subject. We are going to wire up our RC522 adapter to our ESP8266 microcontroller. Then we are going to perform readings of some basic information from this card and tag. Immediately after that we are going to write some data to this card, and later on we are going to read that data from it. RC522 can be connected to ESP8266 or ESP32 by I2C and by UART2, but for this episode we are going to use SPI communication. And of course for that we need our RC522, our microcontroller, and some wires. So let's do it. I'm going to move this aside. I'm going to connect this adapter to my breadboard. So we are going to connect 3.3 volts to 3.3 volts. Then we are going to connect ground. Let me see. Third pin is ground. Now we need to connect a reset pin, that is second from the right. And I'm going to use D3 pin from my microcontroller for reset. Then clock pin from adapter to D5. Then SDA, it's here, but this is actually chip select. We are going to connect to D8. Now master in, slave out. Let me see where it is. MISO is going to be connected to D6. And master out, slave in, we are going to connect to D7. Okay, this part is done, so now let's get to coding. Alright, now first thing that we have to do, we have to include some libraries. So I'm going to include wire first, then SPI, and at the end RC522 library. If you don't have this library installed, first go to your platform IO, go to open, go to libraries and type RC522. Let me see, it's this one. So you need this library. Okay, then just go to add project, and you should be able to find this declaration under your platform INI. Alright, so when you do that, make some space, and first we are going to create integer RST pin, and it's going to be D3. So we are using D3 pin from our microcontroller as reset pin for our RC522. And we need one more. We need SS pin. That's D8. Now we have to initialize our library MFRC522 with the same name, and we're going to provide two arguments. First is going to be our SS pin, and second is going to be our reset pin. Now we have to create two keys. Don't worry, later on I'm going to explain everything. So we are going to use from this library my fair key, call it key A, and one more RFID-RC522 from this library, my fair key, call it key B. Alright, now in our void setup, first I'm going to initialize my serial monitor with baud rate of 9600. Then we are going to initialize our serial communication with SPI begin. Then we are going to initialize our RC522 with MFRC522 PCD init. Then we are going to write some data from this module to our screen with MFRC522 PCD dump version to serial, and I'm going to print something like println scanning commenced. Okay, now I'm going to write my keys. As I said, don't worry, I'm going to explain everything later on. So byte I equals 0, I less than 6, I plus plus, and then first key A, key byte with index of I is going to be hexadecimal FF, and now I'm going to copy this. So we are going to do this for both keys. Damn. Okay, now for key B. It maybe looks complicated at the beginning, but later on everything is going to become clear. So now we are done with our setup void. Now we are going to deal with void loop. Okay. First I'm going to check is new card present. So if we don't have any new card, we are just going to return. And of course, if there is no card or tag, there is no code to be executed. Next thing that we are going to check, if read card serial, and also we are going to return. The second statement actually means if there is nothing to read from, we are going to return, meaning no code is going to be executed. And now, if we actually have some card or some tag and there is something to be read from, now what we are going to do? First, I'm going to create byte sector. It's going to be, sorry, it's going to be 1. So first sector, then block address. I'm going to use block address 4. This is block where we are going to write to, and byte array data block of 16 bytes. This is what we are going to write. Okay, and now I'm going to put some data into this data block with memset. So to data block, I want to put some content like hexadecimal AA. Okay, and I want to put 16 of these values. Now what we need to do, we need to create one byte, call it status, And now we are going to authenticate. Not antenna. Authenticate. First we are going to provide RFID-RC522 library, PICC. We are going to authenticate key B, and we are going to authenticate on block number 7. Don't worry, I'm going to explain everything why I'm doing it. Now we have to provide address of key B. We are using key B for this case, and we have to provide address of our object UID. All right, and now we are going to check if our authentication is successful. So if status not RC522 status OK, meaning our authentication is not successful, we are going to print something. Something like this, and we are unable to continue with execution, so we are going to return. There is nothing to be done else. If our authentication is successful, we are going to create another object from the same library, status code, call it ST. And now we are going to write something to our card. So with status, we are going to receive status MFRC522, my fair write, and we are writing to block number 4, or we could use block address. It's totally okay. What we are writing? We are writing data block, and how many bytes? 16. Okay, and now we are going to check status code. Okay, I'm going to copy this piece of code in here. So I'm going to check ST. Writing problem or writing error. And what else we can do in here? We could actually ask for more data with serial print ln mfrc get status code name for code st. Alright, and now I want to print data from my card. How I'm going to do that? First I'm going to make some space, println, just println, and now we are going to print data from our sector. So mfrc55 picc underscore dump my fair classic sensor to serial. Okay, I believe that that's right function. So first what I'm going to do, I'm going to provide address of my object UID. Second argument is going to be my key, so key B. And third argument is going to be number of sector that we want to read from first sector, meaning from sector with index 1. That's actually second sector. And now I'm going to print another empty line. All right, and now I want to print data from entire card with mfrc522 PICC dump to serial, and what we are going to dump, we are going to provide address of our object, MFR C522 and UID. That's right. And at the end we have to do some housekeeping stuff. MFR C522. Yes, this one, halt A, and another one, MFR C522 PCD stop crypto 1. All right. Okay, why I have error in here? No, not this. It's this function. Okay, so our code is ready, and now I'm going to build it first. Okay, what's the problem in here? It doesn't matter. Okay, I'm going to upload this piece of code to my microcontroller. Alright, I'm going to open my serial monitor and I'm going to restart my microcontroller now. Okay, you can see something now. So what we have in here, we have firmware version 92, meaning version 2, and we have started with scanning. And one more word, you have to keep your tag or card pressed to sensor until entire reading is completed. So now I'm just going to use my card and I'm going to press it to my sensor. Alright, so what is all of this? First, let me explain you how data is arranged on your card or your tag. You have 16 sectors, so this chunk of data, it's first sector. This chunk of data is second sector. So you have 16 sectors from 0 to 15. And now every sector holds 4 blocks. This one row of data, it is what is called block of data. And first block in every sector contains some additional data. And what that actually is, first you have 6 bytes for key A. Then you have 4 bytes. These 4 bytes are called access bytes. And you have another 6 bytes for key B. Block number 0 contains additional information about entire card or about entire tag, like manufacturer ID and identification number for that card. Then these blocks that contain additional information per sector or per entire card are called tile blocks. These other blocks, as you can see with a bunch of zeros, are what is called data blocks. We can write data to these blocks, as we did with our block 4. This bunch of A's, it's what we actually just written. And now, if you recall what we did, we performed writing on block address, and block address it's actually number 4. So we performed writing on block 4, but we actually did authentication on block 7. Why is that? Let me show you. Because we authenticate on a tile block for that sector, you need to authenticate on tile block if you want to use some of its data blocks. So now let's go up and let's see what we have in here. We have some additional data for our card. So we have our card UID, we have a card SA key and a PIC type. And in this part here, we have printed the content from our sector with index 1. And as you can see, this sector contains blocks 7 and 4. On block number 7, we authenticated and we stored our data on block number 4. So guys, this is just a basic introduction into this subject. This is really deep subject and there is a lot to be learned in here. So I hope that you learned something interesting. So please like, subscribe and see ya!